Hello, everyone. Welcome back. So if you have not looked at the quiz yet, go ahead and do that. So head on over to my courses, the quizzes tab, and you will see quiz 1 is available. So go ahead and do that. I'll give you a few minutes and I'll start about 23 after, maybe 25 after. Okay, so now today we're going to look at chapter 2, and hopefully we can work on a team assignment after this. So I'm going to share my screen here. Okay. Let me see if I can, there we go, minimize some of this. There. Okay, so hopefully this will be clear. There we go. Clear a little bit. All right. So today we're going to look at chapter 2. And in chapter 2, we're going to talk about organizing our data. So we have a couple different ways of organizing our data, and one is putting it into a table and actually truly just organizing it. And then we can also look at it graphically, and that organizes it for us as well. And that's a nice visual for us. So we're going to start with organizing it by table. And this is my frequency distribution. In a frequency distribution, we'll talk about a couple different things. And first off is frequency. And this is how often a category occurs. I'm kind of bumping into my computer. I have to move that. Okay. How often a category occurs, and we have our frequency distribution. I'm going to abbreviate a little bit to save space. And this just lists all categories and their frequencies. Okay. And then we have what we call a relative frequency distribution, or just relative frequency. And this is the proportion or the percentage of times that a category occurs. So let's just take a look at a quick example of this. I like to change up my colors a little bit here. So for example, if we have different colors that people are wearing today, okay? I'm going to show you what the distribution looks like. So I'm going to organize it by color, maybe the color shirt they have on, and then frequency, and then the relative frequency. So maybe the different colors, we have red, blue, and green. So maybe you have one person wearing red, 4 wearing blue, 3 wearing green. And my relative frequency is going to depend on the total. So what I'm going to do is I'm just going to total this up. So I have 8 here. And I can write my relative frequency multiple ways. It's the proportion or the percentage. So I can write it as 1 out of 8, or I can actually divide it and write it as a decimal, which is 0.125. And I really don't care. So when I ask you for something like this, I don't care how you write it. Whatever works for you in your group. I'm really not that picky about it. So you can write it as a fraction or a decimal kind of thing. Okay, so that's this right here. This is an example of a frequency distribution. It lists my categories, how often they occur, and the proportion of how often they occur.
Are these definitions in the textbook that you're writing down?
I would think so. I think so. I can't
All
tell
right.
you for sure, but I think so. That's an awesome question. I would guess that frequency distribution, and relative frequency, but remember, I'm going to upload everything I'm writing right now, to my courses. So you'll see it
Okay,
there.
yeah, I just missed I couldn't write it down in time, so I was just asking that.
Oh,
Yeah.
okay. Yeah, so you'll see it again, or you can look in your book. I'm guessing it is in your book. I don't want to say yes for sure because I don't know for sure, but I'm guessing. Okay, so let's talk about a couple different graphs that we might see. And we have the two different types of data, right? So we have our categorical data. So let me separate it out here. So for my categorical data, remember this is qualitative. So my qualitative data, that's a category. So the different graphs we may see for this, the bar graph, which I know we've seen before. Just watching the news, you're going to see a bar graph. And when we're looking at a bar graph is going to use frequencies. Or it can use the relative frequencies. To show the height of each bar. And there's one bar for each category. And the other thing we might look at here is a pie chart. And again, this is something you see often just in life. And I'm sure most of you have seen these before, I'm hoping. And for a pie chart, you just have one piece of the pie for each category. And this uses the relative frequency. So for a pie chart, you're going to use the relative frequency. So that's that percentage. Okay. And you just have one piece for each piece of the pie, one category. Okay. Keep in mind for the bar graph, you may see this in a vertical way or horizontal. So I know when you think bar graph, you think automatically you're going to see these vertical bars go up and down, but sometimes you might see them horizontal. So going sideways, it's just a different view. And these graphs are going to be used to describe the distribution, and we can interpret that. And when we interpret a distribution, we typically talk about a few things, and we're not going to get to that quite yet. But one of the things is we could talk about the mode. And the mode is just which category occurs the most. So which one has the biggest piece of the pie, or which one has the tallest bar, that kind of thing, okay? So the other type of data is our numerical data. Remember, numerical data is quantitative. Quantitative data, okay? And so for here, we're going to see a couple different graphs. And one is called a dot plot. Now, I don't really use this one that much, but I like to mention it. Some of us have seen it and some have not. It's very similar to a bar graph, like the idea of that. It's just not bars, it's dots. It's that simple, but I will show you just so you guys know. So you know. So this dot plot is going to be used for discrete data. So remember, under numerical, we have two different types under numerical, which is discrete and continuous. So this is used for discrete. And you just have a dot above the observation for each observed occurrence, okay? So I'll just say a dot for each time it is observed. Okay. The other one is the histogram. We use a histogram a lot. A histogram looks just like a bar graph, except for the bars touch. Okay, so that's how you know the difference between the bar graph and the histogram. Bars do not touch in the bar graph. The histogram, the bars touch. That's what it is. Okay, that's the difference. The histogram can be used for both types of numerical data. So this is for discrete and continuous data. Okay, and since it's very similar to the bar graph, you're going to use the frequencies or relative frequency for the height of the bar. Okay. Okay, so let's take a look at a couple examples. So we feel pretty good about these. So I didn't get to look at our survey to use for our class, but I have data from last semester, so I'm going to use that right now. And I looked at the number of tattoos for people in this class I had, and their frequencies. So right now I'm actually making the frequency distribution table, and it's just very simple. I'm not going to go overboard and make it fancy. I don't need to do that. So number of tattoos, someone could have 0 tattoos, 1, 2, 3, and 4. 4 was the max that I had for the answers in this class. Not our class, but in the class from last semester. So I had 15 people say that they had 0 tattoos, 10 people said 1, 8 people said they had 2, 2 people said they had 3, and 1 person said they have 4 tattoos. Now, we did this already in the first activity. We wanted to know what type of data this is, and you can see it's countable, right? Someone could answer 0, 1, 2, 3, 4. So this is discrete. So I just want to make a little note of this. I'm going to write it right above it. Obviously not very big. That marker is very thin. Okay, so discrete data. There we go. Just focusing my camera. Okay, so this is discrete data. So I'm going to go back to my numerical and I'm going to look at my options. I can either use a dot plot or a histogram. We're going to look at both real quick because it's not going to take me very long. It's a small set of data. So let's take a look at the histogram first. Like I said, we're going to use this often. Even if you move on to stat 2, you might use these. So it's just nice to get familiar with them right away. So what I'm going to do is I'm going to have like an X and Y axes. So my horizontal, my vertical, and along the bottom, I'm going to put my different options. So 0, 1, 2, 3, and 4. Okay. And here on my vertical axis, I'm going to put my frequencies. That's just what I'm going to use. I'm going to use frequency. You could use relative frequencies. I'm just using frequencies, just what I'm choosing. So let me write this over here, frequencies, and I'm just going to make little tick marks. So I can see I start at 1, I work my way all the way up to 15. So 15 is the max. I'm going to just count by 5s. You know, if I ask you to draw something like this for me, I am not picky. You could count by 1s here, 2s, 3s, whatever you want. You could even just put 15. at the top, and it just gives you some sort of scale. So I am picky about that. I just want some sort of scale. It doesn't matter what it is, just some sort. So, so please make sure you do that for me. Okay, so I'm going to draw a bar, and it's going to be centered over my number. So my occurrence here, okay? So I have someone that has answered 0, that they have 0 tattoos, and for that I have 15. So my bar will be centered over 0. Now this first one probably is always like a little wide because I don't measure it out, right? Oh, okay. I see that you have a fire alarm. Go. Okay, and then the next one, so people that answered, they had 1 tattoo, the frequency is 10. So my bars are going to connect. I'm just going to draw 1 bar right off the other one. And then 2 tattoos, I have 8. So just like this. And then 3 tattoos is 2. And then I have 1 person here. So this is my histogram. It's nothing fancy, but it takes my information and it puts it in a visual for me. Let me move my paper, okay? So I have this nice visual. Now, if I wanted to know what is the mode, now the mode is the most occurring, and right now we are interested in that. The mode would equal 0 tattoos, right? It's the tallest bar, right? That's the one that occurs the most. Okay. Any questions on that one? No questions? Okay. I just checked the chat real quick. All right, so let's take a look. I'm going to get a different color out. I just feel like being kind of colorful here. So let's look at the dot plot. The dot plot's going to look just like this. You're going to get the same information. It just, instead of bars, it's dots. So I'm going to do everything exactly the same. 0, 1, 2, 3, and 4. And I don't have to necessarily put a scale here. You can, but you don't need to. So what I'm going to show you is I'm going to put 15 dots stacked vertically above the 0. Okay, I just spaced them out so we could actually see them, so it looks a little different than this, okay? And then 10 above the 1. And 8. And 2 and 1, okay? This is a dot plot. Like I said, very, very simple. We could still look at this and we could still say, okay, we can see that the mode, so the tallest here, the one with the most dots, is 0 tattoo. So you could still see that from this. So that's the point, that if we're looking at something visually, we want to be able to get something out of it, and we can. And we want to be able to get the same information here and here, and we can do that. So this is for discrete data. Sorry, I got my camera kind of zoomed in. Discrete data, right? And here are the 2 types of visuals that we have, our 2 graphs. Okay. Any questions on either one of those before I move on?
Can I see the definition for histogram again?
Yes. It's not a great one. It's just for discrete or continuous data, and you can use frequencies or relative frequencies.
Okay.
Okay, so here I'm going to look at another example. And now I'm actually going to look at a different type of data. I'm going to look at continuous. I'm going to tell you that up front. So let me write this out real quick. I'm going to write out my frequency distribution. And here we're looking at magnitude of earthquakes. So I have this range. Magnitude can be between 0 and 0.9, or 1.0 to 1.9, 2.0 up to 2.9, 3.0 to 3.9, and so on. So I'm gonna just keep filling this out. Sorry, move this up here. All the way up to the 7s for the data I have here, okay? Now my frequencies. I'm gonna fill them in here. Okay, so here's my frequency distribution. Because I'm trying to write big so you can see it and it's messy, I have to go to another page to actually look at the histogram we're going to draw. So I just wanted to mention that this data is continuous. It is numerical, continuous. Continuous because it's a measurement. It's continuous because an earthquake might not just be 0.89. It could measure at 0.897256, right? That's how I know when I have continuous data. It's not just 1, 2, 3. It's not even just 1.5, 2.5, right? If we said something like we're rounding, then that would be a different story, but we're not. Okay, we're actually taking the measurements. So that's why this is continuous. We'll get used to it. We'll get used to figuring out how to tell if something's continuous or discrete, and it will be very simple if it's not right now. So I'm going to just say continued example. So I'm going to do a histogram here. The dot plot is only for discrete. So here, I'm going to draw a histogram just like I did before, except I am not going to put my labels down here quite yet, okay? So if you notice, I'm going to pull out this other paper. When I had this histogram, I had my bars centered over each answer here, the different answers. We're not going to do this because in this one, it's not just 0, it's not just 1, it's not 2, it's a range, right? So that's how I'm going to list it on my histogram. So over here, I'm still going to put frequency, and I feel like I should left myself more room, but that's okay. Since my frequencies, we'll just take a look at this, they go all the way up to 3,400, I'm gonna just go by thousands. It's not the best, but it gets the job done. So I'm gonna actually write with my smaller marker. So 4,000, 3,000, 2,000, and 1,000. So remember, this is the frequency. This is not my magnitude of earthquake, right? The magnitude is going to go down here, okay, and my horizontal. I'm still going to do the same thing I did before, where I have my bars leading right off my axis, and my bars will all touch because it's still a histogram, okay? So I'm going to look at the first one here. So on this first one, 0 to 0.9, it's 3,371, right? So I'm just going to do my best with this. Let's see, let's choose a different color. So I'm going to just do my best with estimating where this is because my scale is kind of too big to be real accurate, but I'm just going to draw a bar here. And I'm just going to keep going with my bars, and then I'm going to fill this in after. You don't have to wait. I'm going to do it that way. The next one's 3,400, so it just goes up a little bit. I try to make my bars the same width if possible. When you're hand drawing things, I don't expect you to be an artist, so it's okay. It doesn't have to be perfect. So my next one is way down here at 286, and then I go back up to 1,000. So here I'm going to jump up a little bit, and then this one's even smaller, and then the last two are kind of like not much there. Okay, so now I want to put my scale on this. So to put my scale on here, I'm going to show it like a range that it is, right? Because it's not just 1, it's from 0 up to 1, not including 1 for my first bar. So I am just going to put 1 right here. And at the end of the second bar, I am going to put 2 because that's where it ends, right? So this first bar goes from 0 up to 1, not including 1. This starts at 1 and goes up to 2, not including 2, okay? And that's how we label these. It's a range. My last 2 bars aren't very the same width. That's all right. We get the idea, okay? So here you could say magnitude. Be specific of earthquakes if you want. You could put something like that. Okay, so I just want you to make a note that the bars do not include, so like this one, this bar does not include. .0, it just goes up to 2.0. Okay. All right. So this is my continuous histogram. Now I'm hoping you're kind of wondering, where did I come up with all of these? Like if I was given raw data, how did I know to go 0 to 0.9 and 1 to 1.9? And the key is that, first of all, and I hope you notice this, that they're all the same width. They have to all be the same width. You can't have them all over the place. It doesn't make sense. They have to all be the same width. And I'm going to show you how to find that width. And that's just called the class width or class size. So if we want to know how to find this width, so we have our class width, and it's approximate. It's not exact. It's my largest data value. Minus the smallest data value divided by the number of classes that you want. So if you say, okay, I want 8 classes, you're going to take your largest number minus your smallest number and divide it by 8, and you're going to get that a value, and you're going to round. Okay, so let me just write this here. So class width is also called maybe bin width or class size. I'm going to write bin width. I just like to show you all the different words. Okay, so it can be called the bin width. This is not division. I'm feeling like this is going to look like division here. This is not division. This is just another word for it, the bin width. And what you need to do is you need to round your number up. So you will round up when you do this calculation. Okay, so let's just do a quick little example with this. So if you, I'm just going to squeeze it in here. If you wanted to know the class width for like this example here, you don't have the raw data, but I'm going to tell you what it is. So I'm just going to abbreviate my class width. And let's just say that the largest value that I had in my data was 7.6 and that the smallest was 0.3. And I know I want to have 8 bins or 8 classes, so I'm going to divide by 8. So what happens here is I get 0.9125, but I'm going to round to 1. And this is how I found that I'm going to have the bin size equal to 1, where it'll be 0, 1, 2, 3, 4. So if I chose 4, then it would come out to be 2, and it would be 0, 2, 4, 6. Okay, so just so you have an idea, that's how that works. Okay. Any questions so far on that? Okay, no questions. So those are some graphs. I'm not going to go over the bar charts. I think we already know this. I'm not going to go over the pie charts. I think we already know this. We're going to get to an activity next class, and you'll be able to work on that, and you can ask me then. You could look it up in the meantime. You can ask your teammates. Don't be shy, okay? So the next thing I want to talk about is describing the distribution. Which one are you talking about, Jared? Like this one? Okay, so we need to describe the distribution. So we can describe a distribution from looking at the frequency distribution, so the table. We can describe it based on looking at a graph. So I don't want you to think like you have to just have one way. We can describe it from different views. So I have 3 different things that we use to describe a distribution, and these are not going to change throughout the course. So what we call them is shape, center, and spread. So we'll just take a look at this real quick, and I'm not even going to use those words quite yet. I think maybe next class we will do a little bit more with that. But the center we will talk about here, and this is a typical value. I guess I am calling it shape, center, and spread even here. So let's just go right for this. This is what we're going to use all semester. The center is what we would call the typical value. Okay. Right now, what we're looking at here is going to be the mode, like I mentioned, the one that has the highest bar or occurs the most in the frequency distribution. Okay, this is the center, so occurs most frequently. It won't always be this, but it is right now. And the reason why I say that is because how we describe a center may change as we move forward with the class. Okay, so right now it's my most typical value, which is mode. Mode is most, that occurs most frequently. Okay, that's the center. The spread. Okay, so I'm looking here mainly at the range. So I'm looking at the distance from the min value to the max value. Okay, so this is range, which is just my max minus my minimum value. Just tells me how spread out my data is, right? So if it's really large range, that means I have a larger spread. It means it's more spread out. And you can look at that visually even, okay? So we might even ask ourselves a question, something like, is the data equally spread or is it clumped? Let me write this down. So what I mean by that is it all spread out pretty evenly? And you can look at the numbers, or you can look at a graph, or is it like clumped together? Like this example right here, I could see it's kind of clumped together right here, right? It's not quite evenly spread out. Like these bars aren't as high as the other ones. So we kind of get an idea. Okay, just from that. And the last one is the shape. Like I said, shape, center, and spread. I kind of went out of order, but that's okay. Shape, center, and spread. So the first of all, with the shape, we can look at the number of modes. So we typically look at a one mode, like a single mode, or two modes. So it could be unimodal or bimodal. So one mode, I'm gonna kind of try to sketch here real quick. One mode means that I have one, maybe if I'm looking at a histogram, bar that's higher than the others, that occurs more than the others. Okay, this is my one mode here. I could have a histogram that looks something like this. And you can see here, it has two modes. Okay, so that's what I mean. How many modes do we have? A lot of times we see one mode, but once in a while, after all, we are looking at real data. So once in a while we have some things that have multiple modes, and that's okay. So that's part of my shape. And to add to the shape, I want to go further. So if we have one mode, this is a continuation of this. Whoops. Trying to connect my letters here. So if we have one mode, then I want to look at the shape. So if I have one mode, I have three different shapes we're going to consider. So first, we're going to consider what we call symmetric. So when we have symmetric, it's pretty equal. I'm just going to draw a histogram, kind of like the one I already drew before, like this. Oops, my fourth bar isn't very good. But we can look at something like this. This is symmetric. It has one mode. The one mode is in the middle. We have something else that is called right skewed. And right skewed looks something like this. Right skewed means that I have like a trail. Sorry, you couldn't see this. It means that I have this trail to the right. So my mode is to the left, and I have this trail, like kind of like a little tail to the right. That is right skewed. Again, only one mode. And then I have left skew. So let me pull this up so we can view this. So left skewed is just going to be the opposite from the right skewed. So I have all these trailing smaller bars, and then I have my mode to the right. Okay, so you can see this trail to the left. So sometimes you might view this not even as a histogram, but like this like little curve like this. This one would be like this, and you have a trail. This one, the trail is over here, okay, like that. And they're not always perfect, right? I don't want you guys to think that these things are always perfect, because it's not. A lot of times we're just looking at real data and it's not great. We just do the best we can. One more thing with this, I know we only have a couple minutes. I want to talk about outliers. It's not outliners, it's outliers with an R. An outlier, these are called unusual values. And these are values that are far from where most of the data is. So sometimes we even say, sorry, I gotta move this up. This is the outside 5%, which we're not going to use that right now, but we will be using that. So what I mean by an outlier is I may have this random bar, like this random value here, this would be an outlier. It's different from everything else. It's far away from where all the other data is. Okay, so for an example, like an outlier, when we're looking at the tattoo question, would be like if someone answered 15 here, right? And I had like one person that said 15. So the rest of the class is answering basically between 0 and 4 tattoos. And then I have one person that has a lot more than the other people. So it's unusual for the group of people that I surveyed. It would be like 15. Okay, that's what I'm talking about when we're talking about unusual values. Is there any questions on that for today? Okay, so remember I'm gonna have this up on my courses, so you can always review it. Feel free to visit some office hours. Feel free to email me if you guys have any questions at all, and I'm happy to answer anything that you have. All right, well, if you guys don't have any questions, our time is up for today. So I hope you have a great day. Feel free to let me know if you have any questions, and I will see you guys next class.
Have a good day.
Thanks.